So we're going to talk about problem number 6, which talks about we want to reformulate the Laplace transform of second derivative expression to be something depending on the function, the first derivative of function, the initial condition of the function at the derivative first derivative of the function at 0, and the Laplace transform of y. So we want to get rid of the derivative, basically speaking. Well, how do we do it? We are going to talk about this in details in class, but just in case you started earlier, here's my quick instructions for it. So just by looking at this problem, sorry about that, we are going to use integration by parts, which helps to get rid of derivative for us. So to begin with, I'm going to use my y double prime to be dv, which means y prime is going to be my v. Well, I want to be accurate. So technically, I'm having y double prime t dt as my dv. So y prime is v. That is to say my e negative st is supposed to be my u, which tells me negative s e to the negative st dt is my du. So I find my vu dv du. So using integration by parts, I'm going to get my problem to be the same as e to the negative st multiplied by vy prime evaluated at 0 and infinity minus 0 through infinity. And then I end up with, let's see, we had u dv, now I need v du. So I have y prime multiply negative s e to the negative st dt. So the first half of it is going to be, naively speaking, or we can be super accurate, limit a goes to infinity. I'm plugging infinity to t, but it's not accurate. It's essentially taking a number into t, but send that number to infinity. So the first half of it is e to the negative sa multiplied by y prime of a minus e to the negative s times 0 multiplied by y prime of 0. And then let's clean up the second half, this minus negative s. So it's plus s, which is a constant, so I can leave it out. 0, infinity, y prime e to the negative st dt. So I cleaned up my problem just a little bit. Y prime of 0, according to the problem, this is y prime, initial condition at y prime of 0, I write it as y1. So this term is written as y1. E to the 0 is supposed to be 1, so it's 1 times that. And I want to look at the first half of it, which is e to the negative sa. Well, if s and a were both negative, e to the positive infinity doesn't exist. If s were less than 0, my bad, if s were greater than 0, then positive times positive gives me positive infinity, negative of that gives me 0. So I have 0 times y prime of a, which is a finite number. So I end up with a 0. So I'm done with the first half of it. And then, like I said, it's going to be 0, right? So I'm just going to write 0 here to make my notation compact. And then I look at my second half of the problem. Well, my answer doesn't want me to have y prime in the expression, because please write it in terms of initial conditions of y prime, and Laplace transform of y. So I want to get rid of the y prime, so I'm going to do the same way of thinking. If I have y prime dt to be my dv, integration by parts again, I have y equals v, and my e to the negative st is going to be my u. So negative s e to the negative st dt is my du. So my new problem becomes 0 minus 1 times y1 plus s multiply. Okay, this whole expression, I'm going to write it out as integration by parts. So I'm going to have my u times my v evaluated at 0 infinity minus integration 0 to infinity. I had u dv, now I want v du, which is v du, right? Which was my du here. So use integration by parts, I get this expression, so I'm going to clean it up a little bit. Minus y1 add to s multiply. Okay, similar idea. I'm going to plug t values as infinity and 0. So I'm just trying to make it quick. So I just pretend I can submit plug infinity into it. And then minus y of 0 times e to the negative s times 0. Well, I have minus s, so I'm going to have plus s, integration 0 to infinity, y times e to the negative st dt. Okay, I'm cleaning things up. So it's negative y1 added to s multiply. It's the same idea like my discussion before. So when s is positive, this is like 0 times a finite number, so I end up with 0 minus y of 0. According to the problem, it says y of 0, please write it as y0. So I write it like that. E to the 0 is 1. Add to s multiply. Okay, if you look at this expression, you should be super familiar with the definition of a Laplace transform by now. That represents Laplace transform of y. The problem said please use capital Y to represent a Laplace transform of y. So that actually means capital Y. So my problem is going to be simplified as minus s1 minus sy0 plus s squared capital Y. Okay, so that's what I'm going to end up with, and you are going to fill in the blanks accordingly based on what we discussed here.